All right. So first of all, welcome everyone for being here. First, before we get started, thank you very much for Formulate by RELEX and RELEX Solutions for hosting us and doing a presentation in a bit as well. I already saw some hands based on the question of Christoph, who's using ClickHouse already or who haven't heard about it before. And I saw some new people and I saw some people that used it before already, which is great because we got a combination between some expert sessions, almost you can call it, some technical deep dives with Xenia, but also with Alexei. But we also got more on general use cases like Formulate by RELEX is doing, but also on financial use cases. So it's really just, you can learn, ask questions, feel free to do so, of course. And we arranged also after the meetup, so around 8 o'clock, I think, that some pizzas are coming here as well to get some snacks. If you are thirsty or hungry, everything is over here. The toilet is just around the corner. And other than that, have fun. Let us know if you have any questions as well. If after the meetup, you're like, hey, I want to know more or I want to do a deep dive, we're doing actually a free workshop, not too long in the future, like on the 15th and the 15th or the 14th and the 15th of December, but just sit back, enjoy. Let me know if you have any questions and let's start. So without further ado, I will give it to you and you can start with the presentation. I think it's probably best to put it somewhere. Yeah, that's great. Awesome. Thanks. Some water? Okay.
And some water would be nice. Is the sound coming all right? Great. So hi, my name is Devi and I work at Formulate by RELEX, and I'm going to give you a talk about how we've used ClickHouse to solve some of our problems and a bit about the history. So my talk is CRUDy OLAP, saving, revising and slicing large forecasts on the fly. And this might raise more questions than it answers just looking at the title, but hopefully it will be a bit clearer after the talk. So some history. So Formulate was founded like 2013, 2016, was originally more of a consultancy, but became a SaaS startup selling a solution to grocery and pharmacy retailers. And these are basically companies like Coop here in Sweden or Apoteket that have lots of brick and mortar stores, even though we also do online. And the solution we provide is that we analyze their promotions. So here we see someone buying some water on the right side of the screen and say that they ran a promotion 2 for 22 on water last week. We would analyze this promotion, look at how much they usually sell in such a week, probably a lot less in December, November than hottest months of the summer. And would also look at secondary effects, like maybe if people are buying more water, they're buying fewer sodas. And doing all this at a local level, so different behaviors in different stores. And we started using ClickHouse back in 2018, which, as you can see, was before I joined the team. So don't know all of the early history here, but we'll try to give my secondhand account of things. And the reason we went for ClickHouse was that we had these very large dimensional tables that we'll take a look at soon. And we needed to aggregate, show the total sum of the sales and lifts and things like that for a lot of different time points and data points. And previously we had tried to do things in Postgres, and that was just not scalable. Postgres, as some of you know, is a transactional database. So it stores all of its data regarding a row closely together. And when you're going to sum over one of those fields, it's going to be a lot slower than the columnar approach that ClickHouse takes. And so after I joined the team, we started developing our plan module, which is what this talk will center around, and the thing that led us to develop this CRUDy OLAP solution. And then later this year, we were acquired by RELEX Solutions, a Finnish company that does supply chain and retail planning solutions. Very large company, lots of cool products, and we're very happy to be part of their offering and continue developing our features within their organization. And so broad view of data ingestion. So we have the basic separation of some of our batch workflows that we do in the beginning, and then online processing of the results of those workflows. That has to be much more snappy and online because it feeds a web app, and you don't want your users waiting around for like seconds after they change some filter or something. And so to start off with, we get a bunch of CSV JSON files in various ways, REST APIs, SFTP, some put it directly on cloud storage. And we have some microservices that load this straight into BigQuery. And then we have a bunch of analysis in that use BigQuery and Google Cloud Storage for I/O. So export things into cloud storage and then fetch those files into the models that are running. And so sometimes these are very fast models that we can just rerun every time. And sometimes we use pre-trained models, which could be things like saving a lot of coefficients in tables. When you have things that are roughly like a regression, looking at the ratio of things, it's very easy to store that as coefficients that you just load from a table. But sometimes you use more complicated models like decision trees, neural networks, and those we train offline, and then we store them somewhere and have a static configuration of where to fetch this whole model or model parameters when we run things. And so we run these workflows in Uber's Cadence and Apache Beam, and they chug along quite nicely. And at the very end of things, we publish a new set of tables to ClickHouse, where the exciting online stuff is going on. And then we have a more front-end service that is kind of generating various queries and starts this to a web application from ClickHouse. And so the schema we're talking about looks approximately like this. For a single retailer, all of our data is separated by retailers, and we only do analysis for a particular retailer. You don't want your competitors' data to somehow leak you, or like you would like that, but they don't like that. And so you don't want it to go the other way around. And so everything is by retailer. And here you see we have a lot of dimensions in this table. We have the individual items, as you can imagine, quite a lot of them, the single promotion that you're running, the particular store that you're running it in, as I mentioned, very different behavior in a store in central Stockholm, like here, and one of those big maxi stores out in the suburbs. Also, when promotions are running for several weeks, we save each week separately. So you can also get calendrical views of things and how things change over time. And so, as you can imagine, this becomes quite a large table. Promotion of something with different flavors, like the chips over there. If you have, you might have, say, 8 of them for a product that has lots of different flavors. They often run in something like 200 stores. And if this just runs for 3 weeks, we're talking about almost 5,000 rows for a single promotion. So as you can imagine, they run a lot of promotions that we want to analyze. And so this table kind of balloons in size. And we store a bunch of metrics as floats there. So baseline is basically what we expect them to sell a regular week when they're not promoting anything. And we do have some models to tell us what that should be if they're running a promotion that week. We have the total sales. We have our gross lift. And we also have this thing called net lift, where we calculate secondary effects. So as I mentioned, you might buy less of a competitor's product if there's a promotion on the product you're buying. So we want to include the sales that they lose in that way, or maybe people buy less in the future because they've stocked up on something. And so we want to include all of those kinds of effects. Also, a lot of things for fields for filtering things. Very nice in a columnar layout like this is that you can just add on these extra columns for filtering, and you basically don't pay any cost if you don't use them in a particular query. And also we store these secondary effects directly, these cross effects, because sometimes you want to see not just what is the total after the cross effects, but also the individual effects and how much you lose or gain from different kinds. You might buy more of something. For example, a soda might go very well with some chips. We also started storing in a different table for these promotions that is just key by the promotion ID, which is a kind of more dimension table for the promotions, where we have some of these filters, but it's really meant for these CRUD operations that we'll introduce. So as you can imagine, we have some kind of specification for a promotion when you want to create it, and that gets stored into this dimension table. And as a secondary effect of that, we would like to populate this whole promotion table with all of the generated metrics that we get from our models for that. And so that's basically the idea behind the plan module. So we had these batch analyses and they did some forecasting. But what you really want to do when you work with a system like this is not run batch forecasting on all of the things you get from your ERP system, like SAP or something that they run. You want to be able to sit there in the application and say, well, what if I was selling this for not 22 kroner, but 20? Like, how would that improve my bottom line? And so we made this move to create this new module. And so we had to replicate all of these analyses online without using the whole workflows, because we don't want to wait around to start a bunch of things and wait for BigQuery. That takes a lot of time to just spin up a single query. We want it to be snappy and something you can use dynamically. And here we have a dual challenge for data to the model. Like, we need both more input data, more coefficients available in ClickHouse so we can get all of these effects, but also output. How should we store these thousands of rows that we create from doing one simple forecast, or update them? Yeah, support all CRUD operations basically. And so here in this talk, we'll talk about the output, even though there was quite a lot of work involved in updating the inputs as well, and getting those stored in a reasonable way, and also just porting the model code so we could call it from different services. And so with all of this, we added an extra field to our filters, which is the plan ID. So when you're doing scenario planning, you don't want to just do one plan where you put everything in this sandbox. You want to have many different plans. Maybe each person here would have their own plan where they kind of have their personal version of the future, and you want to compare across them. And so that's an extra field that we added, and is part whenever you're making any request, you can just add on this field, and instead of the version of the future that is in your ERP systems, you will get your personal view of the future, but with all of the historic stuff still the same. And so this is kind of our CRUDy OLAP problem, where we get this geometric problem space where, like, as I mentioned, thousands of rows that need to be updated for each upsert, and also these two different tables that we want to update. And what we need in this is really an atomic data visibility. So you don't want to show that half of your stores have the old price when you're updating to 20 kroner from 22. You want to show either all of them with the old or all of them with the new, and no kind of inconsistencies between table. And even though the ClickHouse has some atomicity guarantees, we didn't want to rely on them for things that were this big with such wide tables. And especially so far, ClickHouse hasn't done really transactionality across tables, but here things about that might be coming. So that would be very exciting for us. And want to keep basically the same schema we had for all of the querying. And the conclusion we came to was that we'll use a similar table, basically add a couple of columns for the extra stuff we need for planning. And then we are going to do some tricks that I will show you in just a minute. And as a bonus from the solution, we got a way to keep track of the history. So if you don't like the changes you made, you can go back and view the old version. And so the first trick we did is append only. We decided to go with this common and very excellent pattern. It's documented in some of the ClickHouse docs and kind of corresponds to this common use case of ClickHouse as a way of storing logs or subsequent measurements. And even though this is a bit conceptually different. It works pretty similarly. So we started with adding, in addition to this plan ID field, version field. And so first we were thinking of doing something like just taking the maximal version over the key that we have for the promotion. And when we insert something, we just add one to the max. But as you might see, there are some problems with this. There are some concurrency issues. If we do 2 updates at the same time, both get max version, the same max version, the same increment by 1. So not a problem if we're working on different plans or updating different promotions. But if we have a shared plan and you and me both want to work on the same promotion, this could get pretty gnarly. So it also relies on a lot of ClickHouse atomicity, and doing this max would scan the whole table, or if you do it over a key, everything that's in that key. So quite a lot of scanning whenever you do anything. So not ideal. Our next step was going back to Postgres and using it as a bit of a help. So to solve with these concurrent updates, we decided to lock the plan whenever someone is doing an update to it. And here we use a Postgres sequence for versions. So we have a shared version numbering system. In 64s, there are a lot of them. Hasn't been any problems in the near term. So we just use one sequence for everything. And we also take locks to avoid this concurrency problem I talked about. And here we take a lock on a row corresponding to the plan. So only a single user can modify any plan at a time. And we only take this lock for the final bit of our operations. So not when reading the input data to our models, not when running the forecasts that could be spinning up on different services, just when we write the results of our forecasts to the database. And a final step was to add a versions table where we can say which version each promotion has. So we started with simple mapping from promotion ID to version. And the benefit of that is we no longer need to search for max version. We know which is the relevant version for our promotion. We just need to fetch it. And also, if something is aborted mid-writing, we could have a context cancellation because someone aborts the request, for example, or any number of things could happen. These partial writes would be completely ignored. And it's also very easy to delete things by just setting the version to 0. And so then we have creates, we just append new rows, set a new version for the new promotion ID, and we have updates. We just write a new version and of course deletes by its setting to 0. So we basically have all the CRUD operations this way. And we realized that just keying by promotion ID doesn't really help solve all of our problems, because we want to track one promotion as it might go between different plans. As you can imagine, 21st century, people want to work together in their tools, not just in isolation. So sometimes you could have one promotion going from one plan to another and maybe back again, and we want to track that. So we want to keep track of, have the same promotion ID in these different plans, but then we need to key the version by plan ID as well. So every plan only has one version of the promotion, whatever shows up when you query that plan. But 2 different plans could have different versions of promotion. Also, when we did this migration, we took the opportunity to add some more metadata to better allow us to kind of see this whole history of changes to a promotion. So who made a change, when was it made, in order to kind of allow this interactive view of the past and not just something you can ask one of the engineers to kind of dig out of the database. That's not really a way to run things. And so when it comes to querying things, we get the view of both the past and the future in this way. We do a simple union where we take the historic data from our old table that we had, and then we have this new plan table where we check that the version we have in the plan table is what we should expect in the promotion versions. And this has worked really well for us. And we also filter by plan, of course. And so that's the gist of it. Thank you. PS, we're hiring. My name is Devi. Robin is sitting over there, my manager. Lots of help in this presentation. And we're very excited to talk to anyone about all of this stuff, the promotion planning, the data stuff, also the modeling. And I'll leave some room for questions. I also have a bit of extra content that we can get to, but if people have questions, let's start with those maybe.
My question, do you use replication for tables?
Yes, repeat the question.
Yes, so the question was, do we use replication for tables? No, we use a single ClickHouse instance because that allows us to fit all of our data. And in terms of backups, we copy all of the data we have in these tables into BigQuery in order to roll back things if there will be some accident or something.
Okay. Another question. How many different retailers there are?
The next question was how many different retailers we have. I don't know the latest number of that. Robin, Oleg, do you maybe know how many we're at?
Yeah, it's in the tens.
Yeah,
Okay.
in the tens, so not hundreds yet.
If you had a Postgres before, why don't you just ClickHouse, not, let's say, greenplum, which is basically the same as Postgres with columns?
So yeah, the question was, if we used Postgres before, why did we go to ClickHouse instead of greenplum? And I heard some of that before from Robin, that basically he benchmarked various solutions, and ClickHouse was by far the fastest one. Anything you want to add to that?
That's basic.
Basically.
Yeah.
Okay, cool.
You mentioned that you're using some machine learning models like such as decision tree, etc. How do you have the integration with ClickHouse and those models?
Thank you. The question was, we're using some machine learning models like decision trees. How is our integration with ClickHouse for those? Decision trees, we basically load all of the parameters that go into the decision tree into memory from ClickHouse. And then we send off a request to, I think it's a deployed endpoint for that decision tree, and get the results back. So no direct integration.
From your experience, how is it also getting started to work with ClickHouse? And did you need to change any way or approach?
Thank you. The question was, from my experience, how was it to get started with ClickHouse? Did I need to change anything? I got started with ClickHouse and BigQuery at the same time. So it was slightly confusing that we had these two SQL dialects that were a bit different. And I still to this day sometimes look in the wrong documentation files, but I thought it was pretty straightforward for the ways we used it. We definitely don't use all of ClickHouse most esoteric features, but for the things we needed, I found it pretty straightforward. So then I'll show you some of my bonus content. Our querying evolution, we started off with just using GraphQL for querying because that's something a lot of front-enders like to work in. And we basically had a lot of different GraphQL endpoints where we queried different metrics and aggregated them. And this turned out to be quite cumbersome in terms of development. And large parts of our app are basically different table views that you show. And that's not really what GraphQL is all about. And so we created a custom tabular API that we use for aggregating along different dimensions. So you can send it a request where you want to group things by, for example, the brand, and then you automatically get like all of the filtering and summing up different columns or aggregating in different ways the columns. That made development a lot smoother in that you basically had a kind of catch-all solution and worked really well for us. Going back to this slide, you see that we use select star here. That's not really true, actually. We don't use select stars here. because we found that that's kind of really messy when you have two tables, and you might do schema upgrades to them when you want to add more columns for filtering and things. So we dynamically generate a list of all the fields in a table from a schema type that we save in code. This same schema type is used to generate the create statements for the tables, and we can use it to generate basically a select star statement, but where all of the things are named. But not only are they named, we also have a way of saving a default value for a new column. So if I add, say, a new metric where, say, maybe we store the number of transactions, then I can set the default value of that to 0. And we use this nice table function called hasColumn in table to check whether this transactions field is present in the particular table we're querying. And if it's not, then we just insert this default value instead when we generate the queries. So that has really simplified this migration procedure a lot for us, in that we can do the migrations for the plan and for the historical data separately. For the historical data, we just basically want to republish the things from we have in BigQuery, because we need to generate that data somehow. And for plan, we don't want to rerun all of our historical models. We might have changed to better models since then. So there we use the same default value to create a new column with a default value in ClickHouse. Also filtering, we found that it was very useful to work with builder types in Go. So we have a common filter type we use everywhere, basically, that we generate in GraphQL. And then we have various functions that add on filters for the different dimensions. And this allowed us to start using dimensions tables, where we have an items table, and we can filter, query out what are the relevant item IDs for a particular brand, for example. And then we would be able to use way back in the schema here, the fact that we have this ordered by item. So we don't need to search through all of the items. What brand is this? We can just get out a list of item IDs as an inner query, and then check whether the item ID is in those. And that simplifies things a lot. Any more questions? Okay, thank you.